In this lesson, we're going to talk about rates some more. We've been talking about ratios. The difference between a ratio and a rate is that now we're going to have units of measurement tacked on, and generally with a rate, the units of measurement are going to be different. So, for example, if you look down here at the bottom, you have $27 over 3 pizzas, or you have $9 per pizza. The units tend to be different on top and bottom. A unit rate compares the quantity of one or more unit to one of another quantity. So again, here's $9 for every one pizza, whereas this is just a normal rate. It's $27 for 3 pizzas. So basically, in a unit rate, you guys, your denominator is 1. So if you want to write that down somewhere, the denominator equals 1 in a unit rate, that would be helpful. Equivalent rates have the same unit rate. So if you have two rates that have a unit rate of 5 over 1, that means both of those rates are equivalent. Number 1 is pretty straightforward here. It says the double number line shows the rate at which you earn points for successfully hitting notes in a music video game. Write the rate that represents this situation. So you'll see here that there's several for us to choose from. 0 over 0 isn't ever really a good answer, but 150 over 1, 300 over 2, 450 over 3, 600 over 4, 750 over 5. All of those things could be answers for this one. So you could put 150 over 1 or 300 over 2. You just need to pick one of them. So what the book did for their answer is they picked 600 over 4. But again, any of those things are right. Example 2 is you finding a unit rate. So again, what you want to have happen is your denominator needs to be 0. Generally, it's okay if we put these as decimals because that's what we're a little more used to. But if our ratio is, if our rate is 5 miles over 8 seconds, we tend to put the labels on these. If I want my denominator to be 1, I go ahead and divide. So what I get is 5 divided by 8, I get 0.625 miles per second. So again, decimals are okay here. Tables, you could use a table, but you don't necessarily have to. You just, again, you want to get this number to be 0, so you divide whatever's on top by that. So we have 3 examples here. Write another rate that represents the situation in example 1. If you need to go back there, you can. And then 2 and 3 are a brand new example for you. So again, remember for number 1, hopefully you guys paused and tried these already. But again, remember for number 1, we had a whole list of numbers that would work. So for possible answers that you could have, they could have been like 150 over 1, 300 over 2, I believe it was 450 over 3, and then the answer the book gave was 600 over 4, so that one wouldn't be a good one. But any of those other ones would work, any one of those. The next one, it says a Japanese bullet train travels at 558 miles in 3 hours. How far does the train travel every year or every hour? So again, let's write down the information that we know. We have 558 miles in 3 hours, and I want to know how many miles it travels in 1 hour. So again, all I need to do is take 558 divided by 3. When I do that, let's punch that in real quick. 558 divided by 3, I get 186. And that's miles. Units of measurement are important, so don't leave those off. Number 3 says you pay $8 for 16 ounces of turkey. Write a rate that gives the price for each of the ounces of turkey. So if it asks you to write a rate, again, we want to find per ounce of turkey. So if I know in number 3, if I know that I paid $8 for 16 ounces, again, I have to divide by, that's a Z, I have to divide by 8. So if I take, or excuse me, divide by 16. So if I take 8 divided by 16, I think we all know what we get. We would get 0.5. So we would get 50 cents, basically. So 50 cents is what that thing costs per ounce. Again, we saw tables like this. This is kind of what we have. We have to find a unit rate so that we can find a different price, or we could use equivalent ratios. But it says a chef buys 6 pounds of filet for $51, so we'll put $51 over 6 ounce or pounds, lb. What we want to do is we want to figure out what the unit rate is. So I want to figure out what the cost is per pound, so I can figure out how much 9 pounds cost. So when I take 51 divided by 6, I get 850, 8.50. Then in order to get the 9 pounds, to figure out what the 9 pounds would cost, I would multiply 8.5 by 9, and I would get 70. Whoa, let's undo that. I'll erase that. I would get 76.50. So the cost of 9 pounds would be $76.50. This one says you buy 2 pounds of tilapia for $16. So again, we can start by writing our ratio: $16 for 2 pounds. And then it says, what is the cost for 7 pounds? So again, if I want to figure out what the cost of 7 pounds is, I could take 16 divided by 2, and I would get $8. And that would be the cost for 1 pound. Then in order to find the cost of 7, I would want my bottom number to be 7, so I want to multiply my top number by 7 as well, and I would get $56. What you can see that they did above is that they set it up so that each unit, so they said 2 for 16, that means 4 for 32, 6 for 48, 8 for 64, and to find the middle number here, they took the average of the two. But again, I would just set it up like this and just keep it the same the whole time, because that's pretty straightforward here. They were just showing you another method that you could use to find these different ratios. The last one here, it says your download speed is 3 megabytes for every 4 seconds. Part A says how many megabytes can you download in 1 minute. So for part A, you want 60 seconds. I'll just tell you that right now. You want 60 seconds because it says a minute. That's going to be your denominator. And then part B, it says to construct a double number line that represents the situation. How many megabytes can you download in 10 seconds? Again, you don't need to construct a whole table. Let's just do this. Let's just find how many megabytes you can download in 10 seconds. So go ahead and try this on your own. Okay, so if you can download 3 megabytes in every 4 seconds, we're going to put 3 MB on top over 4 seconds. Again, we want to find the unit rate before we do this, so what we're going to do is take 3 divided by 4, and we're going to get 0.75 megabytes per every second. 1 second. And now if I want to find out how many megabytes I can download in a full minute, what I have to do is I have to take 0.75 times 60, because there's 60 seconds in a minute. So I'm going to punch that in, 0.75 times 60, and I would get 45 megabytes. So that's your answer for number 1, 45 megabytes. Again, I'm going to use this same unit rate down here. Instead of constructing a table, I'm just going to take 0.75 times 10, and that's pretty easy. We just shift the decimal. We get 7.5 megabytes. So again, this lesson is just making sure you follow your units and understanding what you're plugging in and why you're finding the unit rate the whole time. You can go ahead and get started on the homework now. It's posted on the calendar for this week.